Wow, now by this stage of the exam, you're going, come on, give me something that's a bit more interesting, right? So what's all this easy stuff from before? So you think, oh, there we go. This looks more interesting. I haven't even got a whole circle anymore. And, oh no, it's the last. So it's a bittersweet moment, isn't it? Where you're like, yes, now it's starting to get interesting. And then this is going to be it. Okay, right. Whatever. Haha, good one. So what we need to try here is, how are we going to get into this question? Let's do what we've always been doing. Check that everything that's been given here is in the diagram. It might be worthwhile to, with your highlighter. Isn't there a highlighter markup? Do you think that's a text highlighter? I think that's actually for highlighting text. Okay, so it might be useful to get your highlighter out. I think I can do this. So you learn things new every day. So you can highlight maybe your circle. So that, and the circle's going to carry on. I'm not going to draw it because that's what happens when you try and carry on the circle. Circle's generally a lot bigger. Note that when you ever see pictures of a lunar eclipse and shadows on the moon and the earth. Okay, other things, things inside the circle might be useful, but maybe not. So you might just start highlighting some things, maybe not. I always think it would be cool if you had like 4 copies of this diagram, or like transparencies or technology to do it like this so you can get into it. Okay, so let's find some things. We're going to use that circle in some way. Are there tangents, or there's something, or anyway. DA is a look at that. DA is a tangent to the circle at A. DA is the tangent. Okay, so that bit there is a tangent to the circle here. Okay, when you see tangents, few theorems come to mind. There's no center. We don't know where the center is. It's sitting over here somewhere. Looks like it would be about there. So we don't have a center, so we're not using tan rad. Tan chord must surely come up somewhere, right? Maybe not, but tan chord seems useful. The other one is tans from same point. So tans from same point. Maybe, I don't know, and you're not writing these down necessarily, but these are just some of the things that are maybe coming to your mind and going, hey, cool, maybe I've got tan chord somewhere, so maybe I could find a tan chord, maybe not. Well, there's a tangent, there's a chord, so I could find, well, there we go. That angle's the same as that angle. It's just, even if you haven't seen it yet, it's just there in the back of your mind. Okay, and I'm getting rid of this triangle because I don't know why it's there. Okay, then DB, there's another tangent over here. So let's go for our tangent here. No, that's not a tangent. That's a tangent over here. Again, you're thinking maybe some one of these things. Well, if you could find a tangent and a chord, then you could find tan chord. Cool. Well, that's useful. X. There's another X. Okay, there's our badly drawn tangent. Let's get it a little bit better. Okay, so there's our tangent. AF equals FB. AF equals FB. How could that be useful? I mean, if you had a triangle and 2 sides were equal, wouldn't that be just hunky-dory? Great album, by the way. Yeah. So just the reason I'm saying this, to go, these are the things that we need to just start thinking, oh, well, let's look for triangles, isosceles triangles, tangents, okay. And you're going through this a bit quicker, but also just steadily. DC is parallel to FB. Okay, where are these things? There, and there. So we've got, let's go blue. So DC, something's parallel. We already did this in a previous one, but maybe you weren't here for it. Well, parallel lines, we start thinking of corresponding. We think of alternate angles, and we think of cointerior, where it equals 180. So those are the types of things that are just sitting there going, I'm sure we must be using something like that. Like, there we go, there's some corresponding angles. Or maybe, I don't know, there's some that's the type of thing that we should expect to come up somewhere. AB produced meets DE. AB produced, it just means carries on. Meets DE, produced at C. So those lines, let's get rid of that, degrees. So we've got something else going on here. We've got these things reach at C. So basically they're straight lines and they come from the same point. So if at some stage we've got that, maybe there's a triangle or there's a triangle or something like that. Not quite sure it's going to be useful yet. But they're straight lines. That's quite useful so that we can start using angles in a straight line, maybe over there, angles in a straight line, that type of thing. Okay, well, those are all the things that we've been given. This here, just by the way, tans from same point. Remember that one might not look so obvious because we're used to seeing the tan set on the circle, but now some of the circle is not here, but still that's going to be the same as that, tans from same point. Maybe you can make an isosceles triangle. There we go, that's all you need, because now we've got all the things that we need to be able to go into this. Prove ABED is a cyclic quadrilateral. Now another way to ask this might be, well, there's x, what else is equal to x? Is there anything that's 180 minus x? So if we're proving something's a cyclic quadrilateral, what are the properties of cyclic quadrilaterals? Because if we can show that, then we can show it's cyclic quadrilateral. So what I'm asking out of all of that is, yeah, let's imagine you had a cyclic quadrilateral. Well, if you've got one there, then you know that should be 180 minus. So if you could show that this is 180 minus that, you've shown that it's cyclic quadrilateral. That might be one way to do it. Another way to do it might be to go, well, we've got, if something's a cyclic quadrilateral, then we also know we've used that if we had something like this, then angles in same sig. So that's great. And conversely, if you can show angles in same sig, so if you can show that, then it must be a cyclic quad. So these are the types of things that we need to prove. I don't know which one we're going to use because it might not be immediately obvious. But to get into the question, we've kind of got a sense of what's going on. We've got a whole lot of things that we go, oh, wow, there's so many we could probably use. ABED, ABED. So in other words, if you drew a circle, a terrible looking circle like that, and again it will go further around, is that a cyclic quadrilateral? Can you draw a quadrilateral through all of those points? So can you show one of these things? Leave it to you. Try and hunt around. Hint, you've got x. See if you can show a whole lot of other angles are x. Try and work them out in terms of x. That's x, that's 180 minus x, that's 360 divided by 3 plus x, whatever it is. So that's what you're going to try and do. And then for the last part, prove ABE equals 3A1. Now A1 is x. So in other words, all you need to try and prove is that, let's turn this transparency all the way up. So all you need to prove here, ABE is 3A1. ABE, where is that? Over here. So if you can show that this whole angle here is 3x because this angle is x, then you're good to go. I don't know where it's going to go, but maybe you work out that that's x, that's x, that's x. Great stuff. You're going to be hunting around. This is going to be a fun question. And please, I beg of you, don't just scroll through. Oh, Bemo, what is it? Where do we get to? Fiddle around, play around. If you didn't see the video earlier, when I talked about one of these previous questions, I said, not that one, that wasn't interesting. Like the question 2. Go back to question 2. Solve everything. Solve it in a number of different ways. Don't just be, oh, find x, y, and z, and that was easy, and move on. Yeah, I got my 7 marks. No. Not now when we're practicing. Practice. Find out, what's this angle here? Could I see that this was an isosceles triangle? Could I find out angles in same seg? Was there a cyclic quadrilateral? Could I prove something else? Play around, and it really helps you so that when you get to the more complicated questions like this one, where it doesn't just say show that this equals x, but you have to do a bit more, you just feel a bit more comfortable and confident in trying and giving it a go. So that's that. On that note, enjoy. Hope it all goes well. Best of luck.